And the final lesson in this sort of series of lessons is probably going to be your favorite, because this one is going to shorten things up even more. We're now going to learn to use noble gas notation, and noble gas notation's purpose is to keep us from having to write out all of the inner core electrons. We're going to use a symbol to represent inner core, and the symbols are going to be the noble gases, these guys right here. We're going to let, for elements in the second row, we're going to let the inner core be helium, and so we'll just write, if we need to do that, He in brackets. If it's a row 3 element, like aluminum or magnesium or chlorine, we'll start out with neon in brackets, where neon represents full row 1 and row 2, so on and so on. Where if you're on, let's see, row 5, if you're on row 5, 1, 2, 3, 4, 5, then you would use krypton to represent full rows 1 and 4, 1 through 4. You'll love it, I promise. So let's get right to it. My suggestion for doing this, again, you should have your periodic table out, off-ball diagram if you don't have it memorized yet. For hydrogen, we don't really have anything, so it would still be 1s1, or for orbital notation, 1s arrow. And that's a good point here. This noble gas notation applies to both orbital notation and electron configuration. It's for both. Again, for helium, there's no shortcut. Sorry about that. For lithium, though, lithium's on row 2, so technically there is a shortcut. If it's on row 2, that means row 1 is full. We could use helium and then 2s up, or 2s1. Not much of a shortcut. It's about the same amount of writing. So, and the same for boron. So let's skip boron. Who's really interested in that? How about nitrogen? Nitrogen's on row 2, so we could start it with helium, and then 2s, 2, 2p, 3. One good thing this does for us is it very clearly delineates between the inner core and the valence shell. So what you draw on the right will be all the electrons either directly valence, or in the case of the transition metals, at least available for some kind of bonding. Alright, I'm going to skip oxygen as well. Magnesium is on row 3, so row 3 means row 1 and 2 are complete, so that would be neon. Neon represents 10 electrons, so then for magnesium we would start on row 3, 3s, and there are just 2. So that shortens things up quite a bit. For copper, find copper, element 29. It's a transition metal. It's on row 4. So being on row 4 means we go back to the noble gas that ends row 3, and that would be argon. So we begin the valence shell with 4s2, and then we go right into the 3ds according to Aufbau. And then you can count over. Copper is in the 9th box on that row, so that's going to be 3d9. In case you're wondering, the answer is yes. After the bracket, you will always start with an S on that row. Very difficult to miss. All right, we did bismuth last time. Bismuth was a beat down. It was on row 6. Let me double check that. 1, 2, 3, 4, 5, 6. Yes. So we're going to start with a noble gas that ends row 5, xenon. And man, that took away a lot of our writing. So bismuth is on row 6, so I'm going to start with a 6s2. And then according to the Aufbau diagram, after 6s, we finally have the 4f's show up. And then the 5ds, which takes me to mercury. And then the 6p3 for bismuth. Lots shorter. All right, hit pause and see if you can decide which noble gas Rutherfordium needs to start with. Rutherfordium's on row 7, so we're going to start with the noble gas that ends row 6, radon. We'll begin then with 7s2 for the valence shell. After 7s, we would have 5f14, and then, oops, that is a 6d. And again, don't skip actinium. It's a 6d too. I figured you would like that. If you have any questions or don't quite get it or would like to ask something specific about why we do something, come and see me.